Okay, so we are going to talk about application problems solving equations that have our trigonometric functions or periodic functions. Okay, so right here, a trig function has a general equation such as f of x is equal to a times the cosine of bx plus k, or a times the sine of bx plus k. Now, we've been doing things all year long that have transformations within the functions and everything, and A has always represented our vertical compression or stretch. B has represented our horizontal compression or stretch, and K has represented our vertical shift up and down. None of that has changed, except when I'm actually taking stuff and applying it here, it's important to understand what those things are going to do with my equations and therefore my graph. So in this case, K, so this vertical shift, is now going to be called the midline. It is called the midline because it is halfway through my graph. Now, when I say that it is halfway through my graph, basically what I have here, let me go ahead and give you like a gist of like a sine graph. If I was to go ahead and graph a sine function, it would look something like this. Now, that would be one cycle of my sine graph. Now, my midline would be right here in the middle, and it's just a horizontal point right here in the middle. It's going to be that horizontal line through there. So we would call that our midline. It is halfway between the maximum and the minimum. And that makes sense because I can see right here, like this would be a maximum, and this point right here would be a minimum, and it is halfway in between there. Okay. Now, it says that A, absolute value of A, is going to be what we're going to refer to as our amplitude. Amplitude is going to be the distance from the midline to a maximum if added, or a minimum if we subtract it from the midline. Meaning, if I was to go ahead and look at this right here, if I was to go from this midline up to this maximum right here, this line would be adding A. And if I was to go from this midline right here to this minimum right here, this distance would be subtracting A. Likewise, if I was to go from the maximum to the minimum, if I was to do that entire distance from maximum to minimum, that is 2A. If this is A, add those together, that's 2A. Okay, now B, so this interior part here, is going to be used to find the period. The period is how long it takes for one cycle to occur or one repetition, so one length of that. So more or less what I'm looking at right here, this would be one period, because what would happen after this point right here would be it would continue. I'd have a repetition of that, okay? So that's what one period is it's one cycle where before it starts to repeat again. Now, for sine and cosine, we would calculate our period as 2 pi divided by whatever that value there is in B. That tells me how long the period is, or how long from start to finish did it take before it repeats. Okay, so let's use this information and actually apply it and solve these problems. So in this particular case, the average daily high temperature in Seattle is modeled by the function T is equal to negative 15 times the cosine of pi over 6m plus 61, where T is the temperature in degrees Fahrenheit and m is the number of months since the beginning of the year. What is the maximum average daily high temperature? So reading the question, what is the maximum average daily high temperature? Let's go back into the question and see. It says that the average daily high temperature is modeled by the function. So that tells me that the outputs of that equation are the average daily high temperatures. Okay, so now I need to find the maximum average daily high temperature. So let's think about that. I need to find the highest output. If I was to come over here and look at this graph right here, if I wanted to find my maximum, as I have marked right here, this maximum right here, I'd find a maximum by taking whatever my midline is and adding my A value to it. If I was trying to find a minimum, I would also take my midline and subtract the A. But again, when I'm talking about the A, I'm talking about that absolute value of it. So that's an important case here, because here right now, as I look, if I didn't do absolute value, I'd be subtracting, but that's not what I need to do. So we need to go ahead and do midline plus the absolute value of A. So what is my midline here? Well, my midline is the 61. That's what this plus 61 is here. So 61 plus the absolute value of A would be 15. 61 plus 15 equals 76 degrees. So that's the maximum average daily high temperature. If I was to graph this function, my peaks would be at 76. Okay, now what is the value of M when the average daily high temperature is 76 degrees? So when does this happen? That's what this is asking. It wants to know what is M. So when this is equal to 76, what is M? So that means I'm taking that equation. I'm going negative 15 cosine pi over 6 times M plus 61, and I've got to set that equal to 76. And now I just need to solve for M. So this is a little bit different. We've already been doing solving trig equations, and the first step is always going to be the same. Isolate the trig function. So I've got to get this cosine pi over 6m by itself before I do anything. So I'm going to subtract 61 from both sides. And that gets me negative 15 times the cosine of pi over 6m. And that's going to equal positive 15. Okay, again, I've got to get the trig function by itself, so that means I'm going to divide both sides by negative 15. And once I do that, that cancels out over here, so I get cosine of pi over 6m is equal to negative 1. Okay, now I need to go ahead, now that the trig function is by itself, I need to kind of go ahead and get rid of the trig function so that I can work with what's on the inside. So what I'm going to do is I'm going to take the cosine inverse or arc cosine of both sides. So that's what I've got here. And let me write this a little bit better. Okay, so there's what we've got here. So if I take the inverse cosine of cosine, it cancels out. And this just gets me pi over 6m. And this is equal to cosine inverse of negative 1 or arc cosine of negative 1. So when does cosine equal negative 1? Well, you might go, it equals negative 1 at 90 degrees. Well, that would not be wrong. However, it would be wrong in context of this problem. If you notice right here, the B value that is given to me, it's given to me as pi over 6. That right there is telling me that this problem is done in radians. If this problem was done in degrees and my answers could be in degrees, then that right there, instead of saying pi over 6, would say 30 degrees M. It doesn't, so I need to do this in radians. So what radian measure does cosine equal negative 1? That's pi. Okay, so now I can go ahead and take this information and solve for M. So I would go ahead and get rid of the pi over 6 by multiplying by the reciprocal, 6 over pi, to both sides. And when I do that, that cancels, and I get M is equal to 6. And so that's telling me that this happens. What is the value of M? It's when M is equal to 6. Well, in context of the problem, M is the number of months since the beginning of the year, so it's saying it happens in June. The average daily high temperature in Seattle happens in June if all of this is correct. So value of M equals 6. That's what we found over here by doing this math, okay? Okay, number 2. A sprint car with a loud engine is racing around a track. The engine's volume V in decibels is defined as V, where T is the time in minutes since the sprint car has passed your position. Find the appropriate time when the volume will be less than 65 decibels. Okay, so in this case, I have the equation negative 12 sine 2 pi over 15 times T plus 70, and I want to know when is it less than 65. Now, question here is, should I do that as an inequality? Some of you might be tempted to, but I'm just going to say we don't want to do inequalities with this right now, just trust me. We'll get to inequalities next year in AP. What we're going to do right here is I'm just going to go ahead and solve this, okay? So again, follow the same steps as last time. I've got to isolate the trig function right here, so I'm going to subtract 70 from both sides. That gets me negative 12 times the sine of 2 pi over 15t, and this is going to be equal to -5. Then I will divide both sides by -12. And that gets me sine of 2 pi over 15 times t is equal to +5 over 12. Now, at this point in time, just like we did the inverse last time, we're going to do inverse here as well, except here it's not on my unit circle. If I do inverse sine over here, so if I do inverse sine here, it gets rid of sine here, and I have 2 pi over 15t is equal to inverse sine of 5 over 12. Well, right there, this is not on my unit circle. I can't say, hey, what angle does sine equal 5 over 12? I don't know. It happens. I don't know where. So I can't just use my unit circle and have an exact answer, unfortunately. So that's where you'll have to put it in your calculator. When I go to put something like this in my calculator, I need to make sure I'm in the correct mode. In this case, if you notice the problem itself, again, the b value that's given is 2 pi over 15. It's not given as a degree measure. So I need to make sure that my calculator is in radians mode. So I'd hit mode, scroll down, make sure that radian is highlighted and selected, and then I go back home, and then I can go ahead and enter it. So I would do inverse sine, and I would go ahead and do 5 over 12. And that gets me a value of 0.42977. Okay, so let me put this in. So I'm going to have 2 pi over 15t is equal to 0.4297. Okay, now in order to solve for t, the last thing I need to do is I need to go ahead and multiply by the reciprocal of this 2 pi over 15. So I would just multiply by 15 divided by 2 pi. So if I multiply by 15 over 2 pi over here, that gets rid of both of these and gets me t is equal to. And so keeping it exact, I'll take my calculator and I'll go ahead and I'll put this in and I'll multiply by 15 over 2 pi. This way I have an exact decimal that hasn't been rounded until the very end, and it is 1.026. So I have 1.026 seconds, or sorry, minutes, because the problem says that it was in minutes. So that's how long it takes for the volume of the loud engine, sorry, the sprint car. I couldn't remember what kind of car it was. It takes for the sprint car will have a loud engine, and that way it will be less than 65 decibels at that point. Okay. All right. Mrs. Rule's height on a Ferris wheel is modeled by h of t equals 40 sine pi over 18t plus 65, where t is time in minutes and h of t is Mrs. Rule's height in feet. How long has Mrs. Rule been on the Ferris wheel the first time she reaches 80 feet above the ground? Okay, so let's look at that. So right here, we're going to go ahead and take the equation. I have 40 sine pi over 18t plus 65. And I'm setting that equal to 80. The reason I know I'm setting it equal to 80 is because it's asking when I reach 80 feet above the ground, that's that height. And the problem itself says Mrs. Rule's height is modeled by the equation. So again, the output values are what I'm getting when I'm using the equation. Those outputs are going to be the height, whereas the inputs are time. So if it asked at what time was I 80 feet above, then that's what I've got right here. Okay. How long has she been on the Ferris wheel? That's time. It's asking me time, so I'm solving for time. So again, I'm going to follow the same steps as we did before. I'm going to subtract 65 from both sides. So that's going to get me 40 sine pi over 18 t is equal to 15. Okay, and then we're going to divide both sides by 40. So we divide by 40, divide by 40. That gets me sine of pi over 18t is equal to 15 over 40, reduces down, and that gets me 3 over 8. Okay, now 3 over 8 doesn't happen on my unit circle, so I have no idea where this is. So again, I cannot keep it exact. So now if I do inverse sine of both sides, I'm going to have pi over 18 times t is equal to sine inverse of 3 over 8. And so again, I'm going to take my calculator and I would put that sine inverse in there. So I would go ahead and go second sine, and that gets me 3 over 8. And I put it in. Okay. And again, we need this in radians because the question has pi over 18 for B. It doesn't say like 17 degrees. That's a radian measure. So I have 0.3843. Okay. So pi over 18t is equal to 0.3843. Okay. And then again, to solve for t, we're just going to multiply by the reciprocal. 18 over pi times 18 over pi. Gets rid of that. T equals. And again, I'm going to keep my answer exact. So at this point in time, I would just multiply this one by 18 over pi. And once I do that, that's just keeping the continuous thing, keeps my decimal exact, 2.0202. So 2.202. Now, it did tell me in the problem, round to the nearest minute. So my answer should be t equals 2 minutes. Okay. All right, next part. Find h of 4 to the nearest foot. Notice this is not saying that, you know, that's what it's going to be equal to. It's h parentheses 4. And if I come back up here, this is h of t. That's saying t is equal to 4. I'm just plugging that in. Oh, that's a lot easier. Okay, so if that's what I'm doing is I'm just taking my equation and I'm going, okay, I've got 40 times the sine of pi over 18 times 4 plus 65. And I'm just putting that in the calculator. So you can do that. And once you put that in the calculator, you get 90.7115. Now, again, it says to the nearest foot. So that would be 91 feet. Okay. What is the maximum height of Mrs. Rule on the Ferris wheel? Okay, so again, remember how to find the maximum? It's take the midline and add the absolute value of the A. If it was the minimum, take the midline and subtract the absolute value of A. So in this particular case, my midline on this equation is 65. My A absolute value is 40. So I'm going to do 65 plus 40, and that's going to get me 105 feet. That's the maximum height. Okay, last problem here. I know it looks complicated, but it really actually isn't. A robotic arm of length 1 rotates counterclockwise from the point 1, 0 on the unit circle to the point negative root 2 over 2, root 2 over 2. What is the measure of the angle formed by the rotation? So first, let's go ahead and just draw a little bit of a picture here. So I've got my unit circle here. Okay, that's what I've got right there. And so it tells me I have a point 1, 0. Let me adjust just ever so slightly. It's taking too many things. Just trying to get this to be a little bit better. Well, I guess it's not, whatever. All right, so 1, 0. Let's call this coordinate point right here 1, 0. Well, that seems kind of familiar. Isn't that our initial point where 0 degrees and 0 radians is? And don't we go counterclockwise from that point to give us our angle measures? Well, sure enough. Okay, so what quadrant would negative root 2 over 2, root 2 over 2 be? It's a negative x, positive y. That puts me in quadrant 2. And these numbers feel familiar, don't they? They do. Those are our pi over 4s or our 45 degrees. And that's going to be exactly what I have right here at 3 pi over 4, or also known as 135 degrees. That's going to be the angle measure that I got while I traced along the outside here, because that robotic arm is just going to go right around and follow the tracing that I just did right here of this, and it would stop right there. And so that angle measure that's formed with this whole thing from here to here is that 3 pi over 4 or 135 degrees. 3 pi over 4 or 135 degrees. Okay? Hopefully this makes some sense to you.